Now that you're starting to think about what you're going to do for your large programming project, there's just a couple of extra things you should take into consideration while you're doing the actual programming. And one of the things you want your project to have is because this is a program that's going to be used by other people, you want to make it as stable as possible. In other words, you don't want it to crash when the user does something when they're in the middle of using it. One of the most common causes of these runtime errors in these programs is when you get some input in from the user and the user enters in something that you don't expect them or the program doesn't expect them to enter. So what I'm going to do in this program here is set up there at the top here. This program will look at some of the ways of preventing runtime errors by checking user input. And we're going to do this through a little snippet of something that might be part of a text-based adventure game. Okay. So one of the most common ways that these runtime errors can occur is, let's say you want the person to enter an integer and they enter a string for some reason, and Turing tries to store this string in this integer variable, can't do it, and then so it crashes. Okay, so we're going to look at some ways of avoiding this. One thing to keep in mind is one way of controlling how your program looks is to use a set screen command here. Here I've got set screen graphics colon 625 by 500. This sets the size of my output display to 625 by 500. And if I put that line in there, that'll make sure that no matter what settings the person has on their version of Turing, their output window is always going to be the size that I want. So things will look exactly the way I want them to do. So let's see what this program does here. We've declared a couple of variables here, direction and steps. We get some information in from the user. We ask the person, should we turn left or right? Then we ask how many steps we should take. And then we do something where we change what happens in the program based on the information that they put in. So we just output walking so many steps in such and such a direction. If their direction is left, if they go more than 6 steps, they get bitten by a snake and they die. And if they take less than 6 steps, they see the snake ahead and they stop, something like that. So let's say, in this first question here, we asked them if we should turn left or right. The person could enter anything that they want right in there. So we want to ensure that they only enter left or right. So make sure they enter left or right. And the way we're going to do this is we are going to enclose this entire thing in a loop. And we're only going to get out of this loop when they actually enter left or right. So we'll say exit when direction, which is where we're storing this, equals left or, I need to close this string here, or direction equals right. Okay. Space this out here a little bit by hitting F2. Okay. Now, what if I can just run this here? Okay, should we turn left or right? Now, if they enter something ridiculous like this, it just keeps asking them again, and it waits for them to enter. Oh, they spelled it wrong, so we have to go back and okay, and then it asks them how many steps they should take. Okay. Now, the other thing that might happen here is, what if they enter right with capital letters, or they have cap locks on, or something like that. So we can take care of that by using a command called strlower. So what we're going to do is we are going to take our direction, and we are going to use this function called str.lower. And what strlower does is it takes a string, such as direction in this case, and it changes it to all lowercase. And then here we store it back into direction. So we read in direction, convert it to lowercase, store it back, replace the string that's stored in direction with this version that's all in lowercase. That way, if they enter something like that they want to turn left with a capital letter, it still recognizes it as a valid answer here. And if we take 3 steps, we see a snake ahead and we stop. More problematic is when we're getting this number of steps in here, we want to make sure that they enter an integer. And often when we get them to enter an integer, we want to limit the size of this integer. So let's say we only want them to have to choose from 0 to 10. So we should say this in here. They should only be able to take 0 to 10 steps here. So how can we make sure that we get an integer here and not something else? Well, once again, we can enclose all of this in a loop. And space this out a little bit. So how many steps should we take? 0 to 10. And we can do an exit when steps is, let's see, greater than or equal to 0, or when it's less than or equal to 10. So this will get us out of that loop when they've entered an integer in the right range. How can we guarantee that they enter an integer and not a string or a real or something like that? The way we do that is we are going to declare ourselves another variable up here at the top. It's going to be a string, and we'll just call it ANS for answer. When we read in the answer here, we're not going to read it in as an integer and put it in this integer variable steps. We're going to store it in this string variable answer. And then we are going to convert it from a string into an integer. But before we do that, we're going to use this command here, this function here, string, get it right? String to OK, or string to integer OK. And this function takes a string as its argument there, and it checks to see if it's okay to convert this string into an integer. So if string OK ants returns true, then we are going to go ahead and convert this using the strint, or string to integer function. So strint takes a string, converts it into an integer, and then we store it back in our the integer variable we had before, steps. And we can put this exit when inside here, and then we close our end if. And let's just space this out a little bit nicer. So let's see what we're doing here. We are asking them how many steps they should take. We're getting in the answer as a string, so we're reading in a string for the answer. Then we're going to check, that's not how you spell check, so let's fix that. Check first if we can convert to an integer. And then if we can convert it to an integer, then the next step down in here we use strint to actually do the conversion. And then once we have it converted to an integer, we can do this checking here to see whether it's in the right range here. So let's run this thing and make sure this actually works. Okay, should we turn left or right? Let's say we say right. How many steps should we take? If we enter in 34, it says, oh, we're walking 34 steps to the left. Now why isn't this working properly? Because I've got this backwards. We want this to be an and instead of an or in here. Okay, so we want it to be both greater than 0 and less than 10. Alright, let's run this again. So we want to go right, let's say, and if we take 34 steps, it just asks us to enter in more steps. If we put in something silly like this, again, it just asks us again. We can try putting in a real, it'll still enter in something like this. Okay, true, it doesn't matter. Until we enter a number in between there and there, then we're good to go 4 steps to the left. So this thing here, this whole getting in of checking your input by getting it in as a string and then trying to do the conversion, this is something you could put in a procedure. Write a little procedure that all it does is read in integers and check to see whether they're in the right range. Okay? But these are just a couple of ways to make your program a little bit more stable so that it doesn't crash as easily.